Welcome back, viewers. After watching our short video about the multiverse theory, many of you have requested a more in-depth explanation of this fascinating topic. We're excited to dive into the details and help you understand this complex concept. However, because there is so much to cover, we've decided to split this video into two parts. In this first part, we'll cover the basics of the multiverse theory, its origins, and the different types of multiverses that exist. In part 2, we'll explore some of the mind-bending implications of this theory and what it means for our understanding of the universe. So buckle up, grab a snack, and let's explore the multiverse theory together. Together we're going to cover 10 super important topics that are totally fascinating. These 10 topics are: Introduction. What is the multiverse theory and why is it important? The history of the multiverse theory. How did the concept of the multiverse theory develop over time? Theoretical foundations. What are the scientific principles that underlie the multiverse theory? The different interpretations of the multiverse theory. What are the different ways that the multiverse theory can be interpreted, and what are the strengths and weaknesses of each interpretation? The evidence for the multiverse theory. What are the observations and experiments that support the multiverse theory, and how convincing is the evidence? Implications for cosmology. How does the multiverse theory change our understanding of the universe as a whole? Implications for physics. How does the multiverse theory change our understanding of the laws of physics, and what new questions does it raise? Philosophical implications. What are the philosophical implications of the multiverse theory, and how does it challenge our assumptions about the nature of reality? Criticisms and controversies. What are the main criticisms of the multiverse theory, and how have these criticisms been addressed? Future directions. What are the areas of research that are currently being pursued in the field of multiverse theory, and what might be the future implications of this research? Chapter 1. Introduction. What is the multiverse theory and why is it important? The multiverse theory is a concept that proposes the existence of multiple parallel universes, each with its own unique set of physical laws, properties, and constants. The idea of a multiverse is not a new one, and has been explored by various scientists, philosophers, and writers throughout history. In recent years, the multiverse theory has gained significant attention and importance in the scientific community, as it has the potential to provide answers to some of the biggest questions in physics and cosmology. For example, the multiverse theory can help explain the fine-tuning of the physical constants that allow life to exist in our universe, as well as the observed properties of the cosmic microwave background radiation. Additionally, the multiverse theory has significant implications for our understanding of the nature of reality, challenging our assumptions about the uniqueness and specialness of our own universe. The concept of a multiverse also has philosophical implications, raising questions about the nature of existence, the role of observation and consciousness, and the limits of scientific knowledge. Overall, the multiverse theory is an exciting and thought-provoking concept that has captured the imagination of scientists, philosophers, and the public alike. By exploring this theory in depth, we can gain a deeper understanding of the universe we inhabit and our place within it. Chapter 2. The history of the multiverse theory. How did the concept of the multiverse theory develop over time? The concept of a multiverse has been explored by many thinkers throughout history, but the modern scientific version of the multiverse theory can be traced back to the early 20th century. In 1913, the German physicist Max Planck proposed the idea of parallel universes as a way to explain the behavior of subatomic particles. The concept was later developed by physicist Hugh Everett in 1957, who proposed the many worlds interpretation of quantum mechanics. This interpretation suggests that the wave function of a quantum system contains all possible outcomes of a measurement, each corresponding to a different universe. In the 1980s and 1990s, the concept of a multiverse gained popularity among cosmologists, as they sought to explain the fine-tuning of the physical constants in our universe. The idea was further developed by physicist André Linde, who proposed the concept of eternal inflation, in which the universe undergoes an exponential expansion, creating an infinite number of bubble universes. Today, the multiverse theory continues to be a topic of active research and debate in the scientific community, with new models and interpretations being proposed and tested. The history of the multiverse theory demonstrates the ongoing evolution of scientific ideas and the complex interplay between theory and observation in the quest to understand the nature of the universe. Chapter 3. The theoretical foundations of the multiverse theory. What are the scientific principles that underlie the multiverse theory? The multiverse theory is grounded in several foundational scientific principles, including quantum mechanics, inflationary cosmology, and string theory. Quantum mechanics is the branch of physics that deals with the behavior of particles on the atomic and subatomic scale. One of the key principles of quantum mechanics is the superposition principle, which states that a particle can exist in multiple states simultaneously. This principle forms the basis of the many worlds interpretation of quantum mechanics, which is one of the key components of the multiverse theory. Inflationary cosmology is a theory that proposes that the universe underwent a period of rapid expansion in the very early moments of its existence. This theory can explain several observed features of the universe, such as its overall uniformity and the distribution of galaxies. It also provides a mechanism for the creation of multiple bubble universes, which are a key component of some versions of the multiverse theory. String theory is a theoretical framework that seeks to unify all the forces of nature, including gravity, into a single, consistent framework. One of the implications of string theory is the existence of extra dimensions beyond the three spatial dimensions that we observe in our everyday lives. These extra dimensions provide a possible mechanism for the creation of multiple universes. Overall, the multiverse theory is grounded in several fundamental scientific principles, which have been developed over decades of research and experimentation. By exploring these principles in more detail, we can gain a deeper understanding of the scientific basis of the multiverse theory. Chapter 4. Types of multiverse. What are the different types of multiverse and how do they differ? There are several different types of multiverse proposed by physicists and cosmologists, each with its own unique set of characteristics and implications. The first type of multiverse is the Level 1 multiverse, also known as the cosmic inflation multiverse. This multiverse is the simplest and most widely accepted version, and it proposes that the universe underwent a rapid period of inflation shortly after the Big Bang. This rapid expansion would have created multiple bubble universes, each with its own unique set of physical laws and constants. The second type of multiverse is the Level 2 multiverse, also known as the quantum mechanics multiverse. This multiverse proposes that every time a quantum measurement is made, the universe splits into multiple universes, each corresponding to a different possible outcome of the measurement. This interpretation of quantum mechanics is known as the many worlds interpretation and is one of the most controversial aspects of the multiverse theory. The third type of multiverse is the Level 3 multiverse, also known as the string theory multiverse. This multiverse proposes that the extra dimensions predicted by string theory could exist in a vast landscape of possible universes, each with its own unique set of physical laws and constants. There are also other proposed types of multiverse, such as the brain world multiverse, which proposes the existence of multiple parallel universes existing on different branes in a higher dimensional space. Overall, the different types of multiverse each have their own unique features and implications, and they continue to be the subject of ongoing research and debate in the scientific community. Chapter 5. Evidence for the multiverse. What evidence supports the existence of the multiverse? Despite its theoretical underpinnings, the multiverse theory has yet to be directly observed, and so its existence remains a topic of debate among scientists. However, there are several lines of indirect evidence that have been proposed to support the idea of a multiverse. One of the main pieces of evidence for the multiverse comes from observations of the cosmic microwave background radiation, CMB, which is the afterglow of the Big Bang. These observations have revealed a pattern of temperature variations in the CMB that is consistent with the predictions of cosmic inflation, which is one of the key mechanisms for the creation of multiple bubble universes in the Level 1 multiverse. Another piece of evidence comes from the observation of fine-tuning in the physical constants of our universe. These constants are believed to be finely tuned in order to allow for the existence of life. Some scientists have proposed that the existence of a multiverse could explain this fine-tuning, as it would allow for a vast number of different universes with different physical laws and constants. Finally, some evidence for the multiverse comes from observations of the large-scale structure of the universe. These observations have revealed structures that are larger than the observable universe, which could be explained by the existence of other bubble universes in the Level 1 multiverse. While these pieces of evidence are not conclusive, they do provide support for the idea of a multiverse and continue to be the subject of ongoing research and investigation in the scientific community. In conclusion, we hope that this first part has given you a solid foundation in the multiverse theory and its many intricacies. As we've explored, this is a concept that has captivated the minds of scientists and enthusiasts alike for decades. However, there is still so much more to discover and explore. We strongly encourage you to tune in to part 2 of our video, where we'll delve even deeper into the implications and realities of the multiverse theory. So, be sure to join us for the next part of this exciting journey.